Pressure is an important concept in physics and can be defined as the force applied perpendicular to the surface of an object per unit area over which that force is distributed. It is important to note the word exerted perpendicular to a given surface. Say for example, you have a flat surface and we have a force in a downward position. As you notice, force is perpendicular to the surface and it is like we can draw a 90-degree angle. Mathematically, pressure is represented as P equal to F over A. The force F in this context is the force exerted perpendicular to a given surface, and the area is the surface over which the force is applied. P here is the pressure, which can be calculated by dividing the force over area. This equation tells us that pressure is inversely proportional to the area over which the force is applied. If the area is large, the pressure is low, and vice versa, assuming the force remains constant. The relationship between force, pressure, and area shows that pressure is directly proportional to force but inversely proportional to area. This means if the force increases while the area remains constant, the pressure increases. Conversely, if the area increases while the force remains constant, the pressure decreases. As we will see later, pressure can act on fluid as well as on solid object. As we discussed in the beginning of this lecture, fluids, unlike solid, do not have a fixed shape and they can flow to take the shape of their container. The molecules in fluid are in constant and random motion. Due to this motion, they frequently collide with each other and with the wall of the container. This collision exerts force on the surface that they are in contact with. This force is what we perceive as a pressure. Unlike in solid, where the force is typically exerted in a specific direction based on how the solid is pushed or pulled, fluid pressure is exerted uniformly in all directions. This is because the molecule in fluid move randomly and they can collide with surface from any directions. As I mentioned in previous slide, the force due to fluid pressures act perpendicular to any surface that it is in contact with. This includes the wall of the container and any object immersed in the fluid. This perpendicular nature of this force is a result of the fluid molecule impacting the surface directly at the point of contact. Therefore, the formula for pressure, which is P equal to F over A, encapsulates the concept that pressure is a result of a force distributed over an area. And as I mentioned earlier, a smaller area with the same force will experience higher pressure and vice versa. And this is the extension of the formula that we just described. A pressure of 1 Pascal is defined as a force of 1 Newton applied to an area of 1 square meter. In previous figure, we can see the force exerted by a fluid is all surfaces it in contact with and acts in all directions. This is why it is often referred to as an omnidirectional. Similarly, when a rubber ball with air filled is immersed inside the water in a vessel, it immediately comes up and floats on water. This shows that water exerts pressure in the upward direction. This force arises due to the pressure difference between the bottom and the top of the object. We will discuss in greater detail about the buoyant force, which is the net upward force exerted on an object submerged in a fluid under the topic Archimedes' principle. That point, meaning to say the